Okay, so we're talking about logarithms, and we knew that we can figure out what x is because we know some powers. So 2 to the 5th power we know is 32. And we know that because that was a really nice one, a friendly one, so to speak. So then logarithms are going to help us answer the question, 2 to what power gives us 27, which we don't know. We probably assume it's a number less than 5, okay? And so we're going to learn today the meaning of logarithms. Here we go. Example 1, convert the logarithmic equation into exponential form. Remember, in your notes, you are writing directions. You need to write example 1 and the directions. Convert the logarithmic equation into exponential form. And we are going to go back to this all the time. So this is one of my things that is kind of silly, but I think that silly things help us to remember them. Okay. And so I came up with this thing. I had a really great teacher, and I learned a lot from her, but I add my own tweaks to things. And at the time I was trying to think of a silly way to remember stuff. I had a bunch of kids in diapers. Okay. Because like when you have kids, then the next 10 years of your life are diapers. Okay. Potty training. Well, yeah, because I had a 5-year-old, a 2.5-year-old, and a baby, an infant, right? So I had a couple of kids that were under like 2, all right? So you're in diapers for a long time. And she was already 5, so she'd already been in diapers. And okay, so sorry. So like 10 years of my life is potty training. Now, so in order to potty train your kids, you gotta, think of clever things to make sure that they remember to clean up after themselves and flush the toilet. Okay, which is really, really important. So first of all, before I get to the rest of my story, how do I know that this is a logarithmic equation? Very good. Okay, very good. You guys are brilliant. Okay. Some other notation here. This is log. We would call this base 2 of 32. If we were to read this, this is what's called the argument. That's what usually is inside the function, okay? The argument of the function, okay? And then we have it's equal to 5. So if I were to read this, I would say log base 2 of 32 equals 5, all right? It's really important that we communicate how to say these kinds of equations. So how would you say this one? Log base 3 of 81 equals 4. Okay, good. Okay, so now that we know some terminology here, so I'm back to potty training my kid. So I would tell them, now how do you drop the log?
In the toilet? Sit down.
And I'm going to say this over and over again. So I want you to write this down.
Oh, boy. Yeah.
All right, and this applies to this scenario. We have a logarithmic equation here. How do you drop a log? Give it a swirly.
Ooh. I don't even know what that means, but
Give it a swirly. Swirly is the magic word here, ladies and gentlemen. And that one word is going to help you remember what you do when you have a logarithm. Okay, how do you drop a log?
give it a
swirly. Okay, so what's a swirly? There, that's the log.
What the police did to me.
All right, so you're going to start with the base. You're going to swirl around the equal side and pick up your power. And it's equal to the argument. Now, do you see the swirl?
Yeah.
Okay. So it's 2 to the power of 5 is equal to 32. And is 2 to the 5th equal to 32? Yes. So this is exponential form. Okay. So right here is exponential form using exponents. Is there a log anymore? No, we dropped it.
What is that?
So we are converting between two forms. It's sort of, it's two equivalent things. It's converting between 0.25 and a fraction of 1/4. They are equivalent. Well, we'll get to that. That's in a couple of days.
Logarithmic?
It's so that you know it's in logarithmic form. Yeah. Ah, interesting question. All right. Letter B. Log base 3 of 81 equals 4. How do you drop a log?
Give it a
Swirly. And that means that you're going to start in the base, circle around the equal sign, and pick up your power. So 3 to the 4th equals the argument, equals 81. This is exponential form. These are equivalent forms. They mean the same thing. They mean the same thing. They look entirely different. Okay? All right, log base 4 of 1/16 equals -2. How do you drop a log? Give it a swirly. Start in the base. You pick up the power. 4 to the -2 power equals 1/16. Does it? Yes, it does.
Is it just going to be an entire
It should.
work of this?
It will.
Because yes, please.
Yes, it is.
Oh my gosh. I am so happy.
All right.
It's going to be this, but like 1,000 times bigger.
Scale 2. Scale 2.
It's going to be this on a gigantic scale.
Now we need to go backwards. Okay? Convert each exponential equation into logarithmic form.
And you do.
Okay?
You go back to see because I'm slow.
Convert to logarithmic form. You got it now? Okay.
Thank you.
Convert each exponential equation into a logarithmic form. So since it's logarithmic form, it's going to have a log in it. Yes, it is. Okay. So we have log. The next thing is this is 13 squared. The base, in this equation here, what is the base? 13, yes. So that is the nice thing. The base is the same. Okay, so this is going to be log base 13, but then the question is of what equals what? Log base 13 of 169 equals 13. How? Why?
Because
Oh, sorry, equals 2. Sorry.
Yes, 13.
Okay, so why? Why is this right?
Because 13 and 2
Well,
make
you
27.
Because if you give it a swirly, then it makes perfect sense. Okay? So this is the logarithmic form, and what's nice is you can always check them just by giving it a quick swirly. Okay?
Give me your answers. Don't get over the water.
All right. So 9 to the 3/2 power equals 27. In logarithmic form, what's that going to be? Log base what?
9.
Base 9 of
47.
equals 3/2. Does it? Really?
No.
What is? I just want to refresh my memory. So if I were to give it a swirly, it'd be 9 to 3/2 equals 27, which is back where we started, which is good. What does 3/2 mean? Just to refresh our minds.
Radical 3.
Something about imaginary
Square root
numbers having to do.
Exponent 3 square rooted.
Okay. Power over index. This was the index, the square root of 9, and then it's got a power of 3 on it. What is the square root of 9?
3.
3. And 3 cubed is 27.
A lot
So
of
remember, those fractional exponents have its power over index. So we got a big power and the index in the radical. Okay? Remember that? All right. Here I have 4 to the -3 equals 1 over 64. That would be log base what? 4 of?
1 over 6.
equals -3. And
1/60.
oh, thank you. Boy, I'm having trouble today. 64. Okay. Thank you. How do you know you did it right?
Swirly.
Swirly. Exactly. Anytime you see a log,
Yeah.
your goal is eventually to give it a swirl. Okay. All right. Questions on those two things? It's easy, right?
There's
Oh,
more.
wait. Sorry.
Darn it!
Not really.
The arrow's pointing out what's.
This is example 3. Evaluate.
Logs.
Bless you. Oh, I still have this.
Take a.
You deserve that, Noel.
All right, here we go. Evaluate each expression. Log base 3 of 81 equals what? Yeah, now we're lost. 4.
Thor.
4. Why?
4 to the third is what?
Because if you give it a swirly, it makes perfect sense. 3 to the 4th equals 81. Okay? It's what is the power? That is the question. What is the power? Okay? So, looking here, letter B, log base 1/2 of 16 equals what?
Oh.
-4 is right. Why?
Because swirly.
Because 1/2 to the -4th. What happens with 1/2 to the -4th? That flips the fraction, which gives you 16. Okay? Okay? Sorry, my 7-year-old says that all the time. All right, ladies and gentlemen, letter C. Log base 5 of 1 over 125. -3. Very good. Why?
Because you
Because
swirl
5.
and you flip and then you offside.
Swirly, yes. The swirly is great. 5 to the -3. That negative creates a fraction. 1 over 5 cubed, which is 1 over 125. Okay? Ooh, tricky.
Uh-oh.
Oh, tricky. Let me flip back a second. Ah, good. We go back. You'll notice here on this one, our argument was larger than our base. Something happened there. I don't know. I was going with things. All right, good. I said that. We have to get to a smaller number here. 27 to what power? 27 to the 1/3. Very good. So 1/3 power would be the cubed root of 27, which is 3. Very good. Do you have questions on those?
No.
Okay. I think this is the last. I don't care. It's important. It's very important. Important that you can read it,
Oh, no,
and it's important that you see me write it. I don't know if you've ever had a teacher who just puts a slide up and it's all worked out, and they don't do it. It's just there.
That is Mr. Conlon.
Okay. We need to figure out what x is. How are you going to figure out what x is?
Calculator.
How do you drop a log?
Give it a
Give it a
swirl.
swirly. 25 to some power equals x. 25 to the 3/2 power is x. Well, now we just have to figure out what that means. What does 25 to the 3/2 mean?
2 in the
Yeah,
index.
bunch
and
of
The
stuff.
2 in the index. Good. And the 3 is the power. Power over index. Power over index. Which means, what's the square root of 25? 5 cubed is 125. All right, was that easy or hard?
I cried.
All right, well, this is a little different, isn't it? But same concept. How do you drop a log? You give it a swirly, which is b to the second power is 36 over 121. How do you solve for b? You square root, because the square root and the square cancel out, and so you get b is 6 over 11. Okay, so I heard Brian say plus or minus, which is fantastic. But we had some conditions for the base in our exponential functions. We had some conditions that our base,
It's greater than 0.
it could not equal 0 and it could not equal 1. All right, and it also, as you said, had to be greater than 0. Our base on our log function also must be greater than 0 only, okay? Which is kind of nice. So that base has to be a positive number, okay? All right, do you have questions for me?
No.
All right, that's it. There you go. You can start CP4.
That's
Okay.
fine. Yeah.